A very warm welcome everyone. Today in this class, we will be continuing the chapter Carbon and its Compound under the subject Science and Technology, Class 9, Unit 18. Now in previous class, we studied about carbon, sources of carbon, allotropes of carbon, as well as both the crystalline and amorphous allotropes of carbon. We also studied about the chemical and physical properties of carbon. Now, we studied about carbon and the chapter's name is Carbon and its Compound. So, in today's class, we will focus on the compound part of this chapter. So, before starting this chapter, I would like to ask you a question. So, what is a compound? Yes, compound, it is a substance that is composed of two or more elements and that are combined chemically in fixed proportion. Now, fixed proportion means elements in compound, they always combine in fixed ratio due to the fundamental principle of chemistry, which is also known as law of constant composition. And this law of constant composition states that a chemical compound always contain element in the same proportion by mass regardless of the amount or the source taken. So, for example, you have water. So, we all know that water is made up of two elements, hydrogen and oxygen. So, two molecules of hydrogen and one molecule of oxygen is present. So, they are found in the ratio 2:1, hydrogen is to oxygen. Now, it does not matter where you take that water from, if you take it from the sea or the ocean or even from the river or rainwater, the water source does not matter, because in water the elements that is combined to form the compound is always in the fixed ratio, that is two molecules of hydrogen combines with one molecule of oxygen. So, due to this law of constant composition, we can say that in a compound, two or more elements always combine in a fixed proportion. And now here is another word called combined chemically. Now, what that means is, for something to be combined chemically, it means that two elements or two or more elements, they combine to form a compound. Now, individual elements have certain properties, but they combine to form a compound, then it changes its property as well. That is, the compound does not have same property as the elements that has combined to form that compound. So, due to this, we can say that they have combined chemically because it changes its entire property. Now, let us take an example of water again. So, in water, there is presence of hydrogen and oxygen element which combines to form the compound water. Now, hydrogen, oxygen and water, they have entirely different properties. Now, hydrogen is a combustible gas, but water, which is also made using the element hydrogen, is not combustible. Similarly, oxygen is a supporter of combustion, but water compound is not a supporter of combustion. So, the elemental property is changed when they form a compound. So, that's why we here use the word combined chemically and in fixed proportion due to the law of constant composition. So, keeping all this in mind, we can define compound as a substance that is composed of two or more elements combined chemically in fixed proportion. Now, compound has usually two types: inorganic compounds and organic compounds. Now, let us start this class by studying a little about organic compound. Now, previously, many years ago, scientists, they used to believe that organic compounds were only produced within the body of living beings by natural processes only. And even according to Berzelius' theory of vitalism, the organic compounds formation could only be achieved by the influence of some vital force that is present in the nature to which human beings had no control over. So, they believed that due to this vital force, organic compound would be produced, and it was impossible to produce organic compound in the laboratory. So, scientists believed these until German chemist Friedrich Wöhler, he synthesized urea in the laboratory by heating ammonium cyanide. Now, urea is an organic compound, and he successfully synthesized an organic compound in the laboratory, which was completely against the theory of vitalism. So what he did was he heated ammonium cyanide for a short period of time, and he got urea, which was an organic compound. And the urea that is used as a fertilizers for plant today was first organic compound to be synthesized in the laboratory. Now, since inorganic compound could also be used to form organic compound in the laboratory, this gave rise to a new revolution in which scientists now begin to experiment and search for new ways to produce organic compound artificially in the laboratory. So now how we can define organic compound is, organic compound is the compounds of carbon. So the compounds of carbon are called as organic compound. But there are certain compounds of carbon that are not considered as organic compounds, such as the oxides of carbon, carbonate, bicarbonate, carbide, and cyanide. So except oxides of carbon, carbonate, bicarbonate, carbide, and cyanide, all the other compounds of carbon are called as organic compound. Now, certain examples of organic compounds are methane, insulin, urea, carbohydrate, methanol, alcohol, etc. Now, the branch of chemistry that entirely deals with the study of organic compounds is also known as organic chemistry. Now, we understood what organic chemistry is. Now, let us study different properties that an organic compound has. Now, the first property is it has covalent bond. So, do you guys remember what is a covalent bond? Yes, covalent bond is a type of chemical bond in which it is formed by sharing of one or more electron between two or more atoms. Now, here I have taken an example of water. Now, water has one oxygen molecule, two hydrogen molecule. And oxygen has 6 valence electron in its outermost orbit. Hydrogen has 1 valence electron in its outermost orbit. Now, for oxygen to reach the stable octet state, it needs additional 2 electron. And hydrogen to reach the stable duplet state, it needs 1 electron. So, what it does is, the hydrogen, 2 atoms of hydrogen, they shares its outermost electron with oxygen, so that each hydrogen atom reaches a stable duplet state, and oxygen also has 8 electrons in its outermost orbit, reaching a stable octet state. Now, this water, that is a compound, it is formed by sharing of one or more electron between two or more atoms. That's why this type of bond is called as covalent bond, and we can say that water has covalent bond. So, organic compound, they have covalent bond. Now, another property is organic compound has low melting and boiling point. Now, since organic compounds are made up of weak covalent bond, it is easier to break that bond. So, that's why when we apply heat to an organic compound, even little amount of heat can overcome the force present in the covalent bond and melting the compound. So, that's why organic compound has low melting and boiling point. Now, another property is it does not dissolve in water. Now, organic compound is a non-polar compound. That is, it does not contain any charge. But water, it is a polar compound. And a non-polar compound, they cannot dissolve in a polar solvent. So, that's why since inorganic compounds are non-polar, it does not dissolve in a polar solvent, which is water. For example, when we put oil on top of water, the oil does not dissolve in water. So, this is also an example of an organic compound that does not dissolve in water. Now, another property of organic compound is they do not ionize. Now, a certain compound that ionize in water means they dissolve in water and they dissociate into ions. Now, since organic compound, they do not dissolve in water, they cannot ionize in water as well. And the final property that we will study is organic compound, they burn easily. Now, organic compound usually has carbon-hydrogen bond or carbon present in it. Now, carbon and hydrogen, they itself are combustible. So, due to presence of this combustible elements, the organic compound can burn easily. Now, we studied a little about organic compound. Now, let us study about inorganic compound. Now, we can define inorganic compound as a type of compound that is derived from the minerals and they lack carbon and hydrogen bond in it. Then those type of compounds are known as inorganic compounds. Some of the examples are water, sodium chloride, carbon dioxide, calcium carbonate, etc. And the branch of chemistry that deals with organic compounds is also known as organic chemistry. Now, you guys might be confused that because in previous class we studied about inorganic sources of carbon, that is inorganic compound that contains carbon in it, and just now I defined inorganic compound as those compound that does not have carbon in it. So these were the sources of carbon, inorganic sources of carbon we studied in previous class: bicarbonates, carbonates, carbides, minerals such as marble, limestone, dolomite, gemstones such as pearl, gases such as carbon monoxide and carbon dioxide. Yes, we studied about all of these things previously, but these all inorganic sources we just study is not an organic compound because they all lie in the exception of the organic compound that we just studied previously. That is, we defined organic compound as compound of carbon but except oxide of carbon, carbonate, bicarbonate, carbide and cyanide. So these carbon containing inorganic compounds are the exceptions of inorganic compound as well as organic compound as well. So the compounds like calcium carbonate or sodium carbonate, even though they contain carbon atom, they do not have an electrovalent bond and they also does not have a hydrogen in it. So that is also a reason why it is considered as inorganic compound rather than organic compound, even though it contains carbon in it. And we also studied that inorganic compounds are those compounds that lacks carbon-hydrogen bond. So since they also do not have hydrogen, so they do not have any carbon-hydrogen bond. That's why even though they contain carbon, they are still considered as inorganic compound. Now, I hope you have understood what I understood and overcome this confusion. So now let us continue by studying the properties of inorganic compound. Now, the first property is it has an electrovalent bond. So what is an electrovalent bond? Yes, it is also a type of chemical bond that is formed by transfer of one or more electron from one atom to another atom, and the formation of bond by the transfer of electron is known as covalent bond. So let us take an example of salt, that is sodium chloride. Now sodium, it has one electron in its outermost orbit, whereas chlorine or chloride has 7 electrons in its outermost orbit. Now, for sodium to reach the stable octet state, it should donate 1 electron, and for chlorine to reach the stable octet state, it should gain 1 electron. So what they do is sodium, they donate its outermost electron, single electron, to chlorine, so that sodium also reaches stable octet state and chlorine also reaches the stable octet state. Now since sodium, it donated 1 electron, so it became electropositive, and chlorine, since it received an electron, it became electronegative, and the bond between this electropositive and electronegative element is known as electrovalent bond. Now, That's why inorganic compound, they have an electrovalent bond. That is, the compound is formed by the transfer of electron between the atoms of the element. Now, another property of inorganic compound is they have high melting and boiling point. Now, electrovalent is a very strong bond. So, the electrovalent, or it is also known as ionic bond, is very strong. So, large amount of thermal energy is required to break this bond, and so that the compound can melt or boil. So, that's why the melting as well as boiling point of inorganic compound is high. Now, they ionize in water and they can pass electricity. Now, inorganic compound are polar substances, and water is also a polar solvent. So, these inorganic compound, they can dissolve in water and they can ionize in water. Now, since they form an electrovalent bond and they have electropositive and electronegative charges, they also can pass electricity. Now, when sodium chloride, it is dissolved in water, it dissociates into sodium, electropositive atom of sodium and electronegative atom of chlorine. Now, another property is they dissolve in water. Now, this is similar to they ionize in water. Since when an inorganic compound, it is a polar substance, water is also a polar solvent. So, that's why inorganic compound can dissolve in water, and since it dissolves in water, they can ionize in water and they can also pass electricity through it. Now, the final property that we will see is they do not burn easily. Now, inorganic compounds are those compounds that does not have carbon-hydrogen bond in it, and they do not, and most of the inorganic compound does not have carbon in it. So, since the compound itself does not have much combustible elements in it, so they do not really burn easily. Now, we studied that organic compound does not dissolve in water, whereas inorganic compound is soluble in water. But organic compound, even though they are not soluble in water, they are soluble in organic solvents such as ether, alcohol, benzene, etc. Whereas inorganic compounds, they are soluble in water, but they are not soluble in inorganic solvent. Now, let us test that if this is correct or not. Now, here I have an organic solvent, that is ethanol, and inorganic solvent, that is water. I also have an organic compound, which is oil, and inorganic compound, that is salt. Now, let us check if organic compound dissolves in organic solvent or inorganic solvent. Now, here you can see that the inorganic compound, that is oil, it has easily dissolved in this organic solvent, that is ethanol. But here you can see that a layer of oil is above this inorganic solvent, that is water. So, from this you can prove that organic compound can be dissolved in organic solvent, whereas organic compound cannot dissolve in water. Now, we have an inorganic compound, that is salt. And here oil, which is an organic solvent, and water, which is an inorganic solvent. Now, let us see what dissolves this inorganic compound. Now, here you can see that the inorganic solvent, that is in water, the salt was dissolved, but here you can see that in organic solvent, that is oil, salt could not dissolve. So from this also we can understand that inorganic compound dissolves in water, but it does not dissolve in organic solvent. Let me ask you another question. Why do you think oil boils faster than water? We have already studied this in the physical properties as well. Yes, it's because oil, it is an organic compound and water is an inorganic compound. Now, the boiling point of organic compound, that is oil, is low, but the boiling point of inorganic compound, that is water, is high. That's why oil boils earlier than water, because oil is an organic compound with low boiling point, whereas water is an inorganic compound with high boiling point. Now let us revise all of those properties we studied and even look at the difference between the organic and the inorganic compound side by side. So the first difference that we will address is the physical state. Now, organic compound, they are found in all state, that is, they are also found in solid, liquid and gaseous state. But inorganic compound, most of them are found in solid state and only a few of them are found in liquid or gaseous state. Now, another difference is chemical bond. So, what type of chemical bond does organic and inorganic compound have? Yes, organic compound has covalent bond and inorganic compound has electrovalent bond. Now, another difference is ionization. Now, which of the compound they ionize when they ionize, and which of the compound they do not ionize in water? Yes, organic compound they do not ionize, but inorganic compound ionizes. Now, solubility. Now, which is soluble in water and which is soluble in organic solvent or inorganic solvent? Yes, organic compound they does not dissolve in water, but they dissolve in organic solvent. We just saw that practically as well. And inorganic compound they dissolves in water, but they do not dissolve in organic solvent, which we also just looked at in the practical as well. Now, another difference is melting and boiling point. Now which has higher melting point and which has lower melting point? Yes, organic compound has low melting point and inorganic compound has higher melting point. Now, which of them can burn easily and which does not burn easily? Yes, organic compound they burn easily, such as, for example, when we burn ghee, oil or petrol or even LPG, then it easily burns. But organic compound such as salt, if we try to burn it, it doesn't burn at all. So we can say that organic compound burns easily, whereas inorganic compound does not burn. Now, we studied about organic and inorganic compounds, and this chapter is about carbon and its compound. So, let us focus on all those organic compounds that has carbon in it and that we use in our daily lives. So, the first one we will look at is the food we eat. Now, the rice, lentils, vegetables and fruits, meat, fish, eggs, as well as milk products, they all contains proteins, carbohydrate, vitamins, fats in it, and all of those compounds they contain carbon in it. So, all the food we take contains carbon in it. Not only that, the clothes we wear is made up of materials such as cotton, silk, jute, and they also contains carbon in it. Now, most of the medicines that we eat when we are sick also contains various organic compound that is present in it. Now, many organic compound is also used as a source of energy, such as petrol, diesel, kerosene. They all are also organic compound which we use as fuel so that it produces energy so that we can ride our vehicle, so that it can move from one place to another due to that energy. So organic compounds such as petrol, diesel, kerosene, spirits also are used as fuel, and they also contain carbon in it. Not only that, the cosmetic products that we use also contains many organic compound in it. Now we have come to an end of this chapter. We studied about carbon, sources of carbon, allotropes of carbon, both crystalline as well as amorphous. We also studied about physical and chemical properties of carbon, and today we studied about organic and inorganic compounds and carbon compounds or organic compounds that contains carbon that we use in our daily life. Now let us test our knowledge about what we studied in this class. Now, the first question that I have for you is, which one of the following is an organic compound? Now, I have four options. The first is NH2 whole 2 CO, calcium CaCO3, SiC, NaHCO3. Now, this is urea, this is calcium carbonate, this is silicon carbide, and this is sodium bicarbonate. Now, which among these are an organic compound? So, let me give you a hint. Now, according to the definition of organic compound must contain carbon, but excluding the oxides of carbon, carbonate, bicarbonate, carbide, and cyanide. And the examples were methane, ethane, methanol, urea, insulin, protein, etc. Now, here in question, we have carbonate, carbide, and bicarbonate. So, these were all the exceptions of organic compound, and the first compound here is urea. So, the correct option is, yes, option first, urea is an organic compound. Now, I have another question for you. So, which one of the four options that I'll give you is the correct option? So, the first is water is an organic solvent. Second is the boiling temperature of wax is high. Third is compound forms by the physical combination of elements. And the final one is benzene is an organic solvent. So, which is the correct option? Yes, it's option 4. Why? Because water is an inorganic solvent. So, this is incorrect. The boiling temperature of wax is high. Now, wax, it is an organic or inorganic compound? Yes, it's organic compound. So, organic compounds boiling temperature is low. So, option second is also incorrect. The third option is compound forms by the physical combination of element, which is also incorrect because compound it forms by the chemical combination of element, not the physical combination. So, third option is also incorrect. Now, we studied that benzene is found in liquid state, and benzene is composed of carbon and hydrogen bonds. So, benzene is an organic solvent. Now, another question. Which one of the following is odd or the exception in the sense of both organic and inorganic compound? Now, I have four options for you: sugar, fat, glucose, and sodium carbide. Now, which of these is an exception in context to both organic and inorganic compound? Yes, it's option 4. Now, sugar, fat, glucose, and sodium carbide, all of them contains carbon in it. So, they should have been organic compound. But carbides are the exception of organic compound. Now, in inorganic compounds, so that's why sodium carbide is an exception in context to organic compound. But in inorganic compound as well, inorganic compound's definition states that it is a compound that does not contain carbon in it. Now, sodium carbide, even it contains carbon in it, but also it is considered as inorganic compound. So, that's why sodium carbide, the fourth option, is an exception or odd in context to or in sense of both organic and inorganic compound. Now, I have a statement and two arguments for you, and among these four options, one of them is correct. Now, let us study both the statements and arguments one by one and find out which is correct and which is incorrect. Now, the first option is compounds of carbon except oxide, carbonate, bicarbonate, carbide and cyanide are organic compound. So is this correct? Yes, it's correct, because this was the definition of organic compounds. Now the first argument, organic compound usually are less soluble in organic solvent than inorganic solvent. Is this correct? No, it's incorrect. Why? We also studied this through our practical as well. Organic compound, they are soluble in organic solvent, but they do not dissolve in inorganic solvents such as water. So that's why the first argument is incorrect. Now the second argument. Generally, boiling temperature of organic compound is less than the inorganic compound. Now, is this correct? Yes, it's correct, because the boiling point of organic compound is low, whereas the boiling point of inorganic compound is high. So from this we found out that the statement is correct and the argument 2 is correct. So that's why the fourth option, that is statement and argument 2 are correct, is the correct option. Now another question. Now find out among these 4 arguments which is correct and which is incorrect. Limestone is an organic source of carbon. Is this correct? No, it's incorrect. Why? Because limestone, even though it contains carbon, we studied that it is an inorganic source of carbon. Now, another statement. Calcium carbonate easily dissolves in organic solvent like ether, alcohol, benzene, etc. Is this correct? No, it's incorrect. Why? Because calcium carbonate is an inorganic compound, and inorganic compound does not dissolve in organic solvent. So that's why the second option is also incorrect. Now the third option. Oil boils faster than water because oil is an organic compound, but water is an inorganic compound. Is this correct? Yes, it's correct, because oil is an organic compound and the boiling temperature of organic compound is low, so it boils faster, whereas water is an inorganic compound. The boiling point of inorganic compound is higher, so water takes higher time to boil. So oil boils faster than water is correct. Now the fourth option. Most of the organic compounds are available in solid state. Is this correct? No, it's incorrect. Why? Because organic compounds are available in all 3 states, solid, liquid and gas. But it is the inorganic compound, those are usually found in solid state, and only a couple of them are found in gaseous or liquid state. So the fourth option is also incorrect. Now I have a project work for you. So what you have to do is look around each other and try to find at least 5. If you can find more than 5, it's good, but you should at least try to find 5 organic compound and another 5 inorganic compound around you, and you have to write the name of that compound and what property was it that from which you identified that substance as organic or inorganic. So you have to write that one property as well. If you can write more properties, it's better, but at least try to write one properties in a chart paper and show it to your science teacher. Now I have an example as to how you can do this project. Now in a chart paper, divide the chart paper into 2 parts, for organic compound and inorganic compound, and list at least 5. If you can find more, it's good. So here I have given you one example of each. So the first organic compound that I found around me was polythene, that is polythene bag, and when I tried to burn it, it burned easily. So from that I found out that polythene is an organic compound because it had very low melting point. Now another thing is, I also found salt, and when I tried to dissolve in water, it easily dissolved in water. Now organic compound cannot dissolve in water because it is an inorganic solvent. But so from that I found out that salt wasn't an organic compound, but it was an inorganic compound, because inorganic compound can only dissolve in water. So this is one example, and like this I would like you to find more examples and list it out like this and show it to your science teacher as well. Now we have come to an end of this class, so I'll see you guys next time.